Hey everybody, I'm back with another video. This time not quite a tutorial, but more like a tips and tricks episode where I kind of go through some of my favorite tips and things that I like to do in Unity that are some maybe well known, maybe others aren't, but I thought I'd share those with you. And this first part will deal with things related to the Unity editor editing environment. And I'll hopefully have some more parts coming later that deal with some other things like scripting and other aspects of Unity. So let's get started. Okay, here's a really quick tip, and one of the first things I realized when I've been working with Unity that's really handy. Unity has a feature where if the game is running, any changes you make to an object aren't saved. They apply while the game is running, but as soon as you stop, everything's restored back to its original values. That's not only good for playing with things while you're debugging, but it also serves a purpose where it lets you preview things in a non-destructive way. So let's say I have this capsule object here. There's nothing else in this scene, but that's fine. And I just want to kind of see what it would look like, at a stretchy scale, and I really want to play with it, but I don't want these changes to be saved. And so I'm going to make all kinds of changes. Let's say, I'm going to play with the scale of it. Maybe I'll mess with the collider and edit that a little bit and change the radius of the collider and move the collider around. Now you can do all this in debug mode, but you have to undo everything. Undo. In this case, all I need to do is I can make as many changes as I want to anything. So the collider I can make changes to. I can change anything I want here in lighting. I can change the scale, the rotation, anything I want. And then as soon as I stop, everything's back to normal. It's like it never happened. So it's very handy if you just want to kind of test stuff out. Now, one bit of warning though is if you decide, like in run mode, that you don't like the color of this object, so it's blue, let's say, and I don't like blue. If you go into the object and you go to the shader and you change this to, say, green, that's permanent. Even if you stop debugging, it's still green. So that one you're going to have to undo. And that's that, and there's a few other examples of that, but you do have to be careful in those cases. But anything in this inspector here, where there's most of the components here besides shaders, can be modified and reset back to their normal values when you stop debugging. Okay, so this tip is basically just to show you how I like to figure out where the origin or the root position of any object is really quickly. If you create a model in something like Blender, which is what I did, I created this robot arm model, and you'll notice these two models look pretty much the same. There is a difference though. This model was exported where its origin is at the base, and this one was exported with its origin somewhere in the middle of the object. When I have this set to center, Unity is just putting the gizmo, this transform gizmo, at the center of the object geometrically, and that's just Unity doing that. But reality of this is that the actual center of the object, or the root position, not the center, but the root position of the object is determined by your 3D software, your 3D editor, in my case Blender. And when it's imported into Unity, Unity treats the object's origin as whatever it came out of that export process. And in this case, by clicking this and setting it to pivot, pivot is showing you where the object's origin is as far as Unity is concerned. This point right here at the base of this robot arm object is its actual position in the world. If this object was gigantic or small, it wouldn't matter. Everything is centered around this position. When I exported this one, maybe I did something wrong or I didn't intend to. It ended up where its position is here instead. And so in Unity, anytime I refer to a transformed position, this is what it's looking at. It's this point in space. And so this point in space governs where that object goes. It also governs how it's scaled. So if I scale, it scales from that position. So if I want to make this object taller and scale to y, notice how it makes everything taller and the bottom grows too, and maybe I don't want that. In this case, since the origin is at the bottom, if I scale the y, it only gets taller from there. It doesn't go down. And so that's where the pivot makes a difference. It also controls where the rotational pivot is as well. So when I rotate this object on one of these axes, you'll see it's rotating about that position. But if I rotate this object about its origin, it spins in down the middle. So see the difference. There's a big difference there. And so that is very important, and any calculations you do regarding the transform's position are going to be from that position in space. So as far as unity is concerned, this position is where the object is in space. If I were to hide all of the geometry, you would still end up with that as its position. It wouldn't matter what the geometry looks like. That's the position of the object. Okay, and just to talk about the other toggle here, which is the toggle between global and local, this is very interesting. It deals with rotation, and when an object is rotated, in which this cube is, its local and global axes will be different. Local is local to itself, so the front of this cube will always be considered the front of the cube when you're in local space. So this blue arrow points towards the front of the cube. If I switch to global space, the blue arrow now points in the direction of the global world space. So this z-axis here, which is the global world space, doesn't the z-axis in the global world space doesn't change. It's always pointing this direction, no matter what the rotation of the object is. So no matter how I rotate this object, that z-axis is always pointing in that direction. But if I change to local, you'll notice as I rotate, the local z-axis is always changing. And again, very useful when you are dealing with the local axes versus the global axes. Sometimes you want to move an object along its own local axis, so I want it to move forward no matter what forward is. And sometimes I just want to move it according to whatever the world space z is, which is this direction. Usually you'll see this in terms of up and down. So world up doesn't usually change if you're in a game where the sky is up and the ground is down. Not all games are like that, but most games, I guess. So up is always up. But when this cube is rotated, its up is now somewhere else. Its up is this way. And so if I wanted to move the cube in that direction, I would use its local up y-axis. And this toggle is strictly for the editor, and it lets you see how an object is positioned relative to the world. All right, so this is really, really quick, but I use this all the time, and I'm sure it's not a surprise or something that's hidden, but just thought I'd bring attention to it anyway, since I get a lot of use out of it. But basically, if you have an object and it's somewhere in the middle of nowhere and you don't even know why or how it happened, maybe you imported it that way, or it's a prefab and the position got saved in a weird state. This transform is all kinds of weird, maybe. I've got like a y value that seems kind of crazy. Rather than having to set everything back to 0, I can just go here to this little gear icon and just hit reset, and the transform gets set back to basically back to zeros, and the scales get set back to 1. And then of course the object is no longer there. I can just double click this and it's immediately focused in view. So that's a handy little tip, and the reset works on every component pretty much, and even if you write your own components, you can customize what reset actually means for that component. I don't use it all that much except for maybe in the transforms, but there's definitely cases where reset comes in handy. And if for whatever reason you didn't mean to, you can always undo the reset by coming here to undo. Okay, so here I have two prefabs that are built slightly differently from each other. One of them has the root of the prefab. This one's called bad. And the root is just the base of this tank object. And the other one, which is the good one, the root is an empty. There's nothing attached to it. It's just a transform. And the reason why I like to do it this way is for many reasons, but one of them is that I can reset the transforms position, as you saw earlier with resetting components, to back to zeros and 1 for scale. So back to basically the defaults. And that allows me to move and scale this object using the root, and does not affect any of the underlying components at all when I do this. Now if I try to do the same thing with this object, you'll see that it's already kind of set up to be the correct position and scale for the base object, which is this brown base here. And because I built the prefab this way, if I scale anything here, it scales everything underneath. And I may not want that. And you'll see, in fact, it is scaled right now because that's the size I want it to be in my scene. But it's also scaling everything underneath it as well. And when you scale a parent and you have children, the parent scale affects the children's behavior. So in this tank example, I've got a tank that has a script running that really just kind of rotates the turret. And if you watch what happens, you can see this tank, which is the correct one, looks good when it's rotating. And this one looks kind of wacky. Something's wrong with it. The rotation doesn't look right. And you can see it's almost like egg-shaped and just doesn't look like it's supposed to look. And the reason for that is because of this. The tank that's built improperly, everything has to be a child of the root. And the root, since it's scaled, is affecting the scale of everything below it, whether it wants it or not. And so this base object is a child of the root, and the scale of the root is affecting its scale as well. And it has its own scale because that's the scale that it should be based on the relative size of it and everything else. And when we rotate it, you can see it's all wacky. Stuff is happening to it that shouldn't be happening to it. That's because its parent is also scaled. In the case of the good tank, the base object, the parent is an empty, and the empty has no scale. And because of that, when the base is rotated, it rotates perfectly. And so that's the main reason why I like to build my prefabs this way. There's other reasons too, including the fact that the script is attached to basically to the base object, this brown thing in the bad tank, and in the good one, the script is just attached to the empty. So there's nothing in here to kind of get in the way. And if I needed to do anything with the script, it can affect everything below it. Whereas here, the script is attached to the base object. So if I ever wanted to change the prefab so that something in addition to this base is part of the tank, I would have to completely rebuild the prefab because there's nothing above this bad tank. In this case, the empty is always the root, and anything I ever want to add to this prefab can go as a child of this one. All right, well, I do this all the time, and you've probably seen me do this already. And maybe everybody knows this, but just in case, it's one of my favorite ways to move objects around in the editor. You can obviously use the gizmos, these arrows, and you probably are familiar with these plane movement boxes so that they'll move along that plane. So if I want to move on the XZ plane, I just use this square. And if I want to move on the ZY plane, I click this one. And if I want to move on the XY plane, I can use this square here. Okay, but that's interesting, and that's great if you want to use your mouse and do it in the editor itself. What I like to do a lot of times, especially with things like rotation, because I don't like having to continuously switch between these, even if I use the keyboard, which is also fine. I don't know, I don't really like the rotation the way it works. I use it sometimes, but I prefer to use rotation over here. So I pick my axis, like say the y-axis, and if you can see my cursor changes to a little arrow, left and right arrow, and if I just click and drag here, I can rotate the y on the y-axis just by dragging my mouse back and forth. So I kind of like that because first of all, it keeps the cursor out of the way. And like down here, kind of sometimes the cursor is in the way and it gets like, you know, I kind of get it in the way. Here it's out of the way. And also if you hold down the shift key, it'll move faster and that helps you get more control. And if you hold down the alt key, it moves a little bit slower. So you have finer control there too. So that gives you kind of all the control you need to do rotation or any kind of transform adjustments here in the inspector. And one other thing I'll mention back to in the editor window, if you hold the shift key down, you'll notice this 3-plane gizmo turns into a single square. This represents screen space. So if I were to click and drag this box, this object is now moving in screen space, which is a little bit different than doing it in any one of the 3 axes. You'll notice that the axes become dim. They're not colored anymore. And as soon as I let go of the mouse, now they're red, green, and red and blue. But holding shift down, they turn gray, and I can kind of move it in screen space. So that no matter what my camera is doing, if I do this, you can see it. It moves kind of in screen space, which is just a different way of manipulating objects. Not sure how useful that is to everybody, but I thought that was kind of cool that it supports that. And one other thing that I guess has been mentioned a million times in tips before, but just to kind of put another instance of it out there, you can do math in these editor boxes in the Unity editor. So if I want a rotation that's exactly you know, based on a calculation, I can say 4 times 312 or whatever I want to put there. You can even do like square, like 2 to the power of 10 if you want, things like that. And so sometimes you want to do a quick calculation, you don't want to bring up a calculator, you can do it right inside one of these boxes. All right, I really like this next tip. This involves using the RECT tool, which is this one right here, which is usually, or kind of was designed for UI for the most part, but it still functions in 3D. So if you pick an object, any object, you'll notice that there's a RECT tool. This box with the blue dots is a RECT tool, and it works in 3 dimensions. And so if you want to stretch an object in one direction but not in the other, it's so much easier to just grab a handle and pull it this way, or grab one of these dots and scale it in 2 directions, then it might be to use the scale tool, because if you try to scale, notice that it scales in both directions, going this way and that way. But if I use the RECT tool, it only goes in one direction. That may or may not be useful in certain situations. Of course, it's doing all kinds of weird things to this cube, but it can come in handy sometimes. And you'll notice as I move the camera, the plane that's used for the transform is automatically adjusted to the one that makes the most sense for the view that I'm in. So as I'm looking down on the object, you'll notice it's now this plane that looks like the XZ plane. And so the effect it has is a little bit dependent on what the object's scale is to begin with, but sometimes this can come in handy for certain kinds of objects that are not 2D objects. Okay, so this one I really like. This is dealing with animation curves, which are built into Unity and are accessible through script and are editable in the inspector. All of that allows you to do some pretty cool things, and some of those things don't even involve animation at all. And in this example, I'm going to show exactly how they can be useful independent of using them for some kind of animation. So in this case, I'm going to use them to figure out how much my health should be restored to. So imagine a game where a player has health, and when they run over a trigger point somewhere on the map, let's say, it restores their health to a certain amount. Now, that certain amount can be either a linear calculation from the current health, maybe it's a flat, just, amount that's always restored back, maybe it's a flat difference between the current health and the new health, or maybe it's something more unique and more interesting, more complex, and something that you want to give maybe a designer control of. And it's a nonlinear calculation, and and on top of that, it's a percentage of the current health that the player has. So to kind of clear all that up, what I'm talking about, let's take a look at the player. So I have a script on the player called player control, and this script does what it says. It controls the player, and there isn't much going on other than some things related to health. So the player starts with a maximum health of 99. Its current health is here, and the health depletion rate. So as the player stands there and does nothing, let's just say that the health is consistently going down at a certain rate, and 2 is just 2 health units per second that it's going down. But here's the interesting part. This health restoration curve, you can see if I do that, is this curve. It's nonlinear. It's something I edited myself, and you can obviously make changes to it. But what this is basically saying is when my health is at its minimum, which is here, or its maximum, which is here, the restoration percentage should be the value determined by the y-axis on this curve. And so you can see, based on the way I want my game designed, when I'm at basically 0 health, I want 100% of the health restored. And that percentage is going to go down the more health that I have. And then let's say I want it to be more linear towards the end. So I can control this very precisely with this curve. And because I've edited this curve in the inspector, it's always accessible to me, and I can change these values anytime I like. So let's take a look at the player control script. So you saw that I have some public variables. The health depletion rate defaults to 1. But the interesting part here, let's just say, is down here at the bottom. When I move the player and it collides with that health zone that you saw over in the upper left corner of the map, it is going to figure out what my current health is as compared to the maximum health and the minimum health, which is 0. And if you watch my previous video on inverse lerp or on Unity Math, you'll understand what that does. But basically it's figuring out what percentage of the way between minimum and maximum is my current health, and that's the value t. So that's a value between 0 and 1. And then that's what you pass into the curve's evaluation function. So the health restoration curve is an animation curve, and you saw it's editable in the Unity editor. And when you evaluate it based on a percentage from 0 to 1, you get a value back. And the value back that I get is also a value between 0 and 1. So I'm going to multiply that by whatever my maximum health is, and then add that to my current health. And just to make sure that I don't go over my max health, I'm just going to make sure that it clamps to that. So yes, this is complex. Yes, this is probably maybe overkill in this case, but just to illustrate that you can have full control over values that come out of the animation curve and use them in any way you like to use them, you can see that there's some real power here, and there's probably a lot better examples than what I've come up with, but this should at least illustrate it. And let me just demonstrate that what that looks like in action. So here I am. My player is the blue player, and as I move him around, this isn't really doing anything, but you can see his health is depleting and it's going down and going down. And when I get to a certain spot on the map, which is this blue rectangle, whatever the health value was at that time, it's restored to a new value. And again, that calculation I showed you is exactly how that's done. And I can move off of it and then back onto it, and again my health is restored to a certain amount. So that's how we use animation curves when we're not dealing with animation at all. Okay, so real quick on this one, I just want to show how just because a component is added by default when you add a game object to your scene doesn't mean you need to keep that component at all in the scene. So let's just say I want to create a cube, and the purpose of this cube is to be some kind of like trigger point on the map. So I don't necessarily even want to render anything, but I do want to use its box collider. So I could have done this in several different ways, but the way I did it is I just created a cube, and the cube comes with the box collider by default, but it also comes with a mesh filter and a mesh renderer, and I only need these if I'm actually rendering a cube. If I just want a collider by itself, I don't need to render the cube at all. So I'm going to remove the mesh renderer and the mesh filter, and I just end up with a collider. So now I have a transform and a collider. I can move this around and it's just a collider by itself. So that's something to keep in mind, is the fewer components you have on an object, the more efficient things will be, the more or less memory you're going to use. And maybe if you're writing a very, very small game, and you're going to run it on a PC, you probably don't care much. But if you're going to run on mobile and you have limited memory or limited CPU, then every little bit can help. So let's just pick another object here. Let's just say we want a plane, and we get a nice big plane here. But let's say we don't care about collisions with this plane. This plane is not going to collide with anything. Nothing's going to collide with it. So we can remove the collider. It's a default component, but we're not using it. Might as well remove it. If we're rendering it, we probably want a shader for it. But if we are not going to have any collisions, then we don't need the collider component. And I'll just mention one more thing. These components, they add up. If you have 2 or 3 in the scene, which is kind of silly, which is what I have here for my example, probably doesn't make that much of a difference. But if you have hundreds or thousands of them in your scene, or if they're in a prefab, everyone contributes to your performance and your memory. So if you remove them and you don't need them, then you will save both. All right, so for this one, I'm just going to show something that I learned not too long ago, but it's actually pretty cool. So we're going to bring back the trusty tank for this example, but I'll show you what I'm referring to. So let's say you want to rotate an element and have it look at something else. So I have my tank's base, which is this kind of turret thing, and it can rotate. And as you can see from the previous example, but let's say I want to have it look at this sphere because that's like the default position I want it to be in the editor. So let's just say I'm a level designer and I want to set up this level such that this tank is pointing at that sphere right at the beginning. Well, I could do it manually, kind of try to estimate where it is, maybe get it right, but there's actually an easier way to do that. Let's just put it over here. If you hold down Shift and Control, make sure your rotation tool is selected. If you hold down Shift Control and you click on the axis that you want to rotate on, in this case the Y-axis, and you start dragging, you can put the cursor over an object and it points directly at that object along that axis. So here it is looking directly at the sphere, and you'll notice as I move off it doesn't move anymore. So you can see it's confined just to that sphere, and the way it works is it's using a raycast and a collider. So this object must have a collider attached to it. If the collider is not there or it's turned off, you'll now notice that this won't work. See, it's not working now. So you must have a collider. Another thing that's important is this must be set to pivot and local, because if you try to obviously rotate around the center, that's going to happen, so that's not going to work. And if you don't put it around local, you might get the wrong axis. So both of those need to be set up properly. So here it is on pivot global. Might not necessarily do what you want it to do. Turn that back on. And so yeah, because it's in the global space here, it's rotating and pointing at a global location and not the local, using the local axis of the object. So when you want that to work properly, this has to be set to local, and then it will work properly. So that's the way to get that to work. All right, so for the final editor tip, I'm going to use the FPS controls to move around the scene. So you know already probably that you can hold down Alt and Control and get the hand and move this way. You can hold down, you can use the mouse wheel to zoom in and out, and you can use Shift and Alt to rotate around. scene. But there's another way to navigate the scene which you may not even be aware of. But if you hold the right mouse button down, you will get a little I and then what looks like an upside down T. Well, that's actually the WASD control scheme on the keyboard. That's a symbol for WASD because it kind of looks like that on the keyboard. But if you use the WASD keys on your keyboard, here I am hitting those keys, A, D, S, and W, you can see it kind of navigates like a first-person shooter would. If you want to go up and down, then you use Q to go down and E to go up. And so if you, for some reason, want to navigate through your scene this way, and if you, as you move your mouse with the right mouse button held down, you can kind of see it rotates as well. If you want to navigate through your scene this way, you can use the keyboard and the mouse, just like you would on an FPS first-person shooter type of game. And finally, there are some options to use with the WASD keyboard navigation. If you come up here to the camera button right here, so if you come up here to the options, you'll see under navigation there's some settings for easing and acceleration of the camera as you move around, and setting of the speed of how fast you actually move around in the environment. So there's just some additional options there. Alright, well that'll do it for this one, and hopefully if you enjoyed this, please like the video, and if you'd like to see more of this type, please subscribe, and I look forward to seeing you in the next one.